Hi everyone, this is a video to go over lesson 6.1, which is on areas between curves. So this unit is going to be applications of integrals. So using what we learned from last unit on how to solve integrals in order to do some applications, mostly on area and volume. So today's application is area, and we're going to be calculating the area between two curves. So like in the box here, it kind of shows an example. Let's say we had the red curve, which is labeled f of x, and the blue curve, which is labeled g of x. If we want to find that yellow area that's shaded in between from A to B, then what we simply do is we integrate from A to B the top function minus the bottom function. So we label yt for the top function and then yb for the bottom function. Okay, so let's just do an example. Okay, so find the area between the parabolas y equals x squared and y equals 2x minus x squared. So for all of the questions you're going to be doing, I'm going to be giving you the graph so that you can tell what the bottom function is and what the top function is. So we need to look at the graph here. We can see that the red curve on my screen is the top function, 2x minus x squared. So we're going to integrate that minus the bottom function, and we'll get the area between the two. It doesn't give us bounds though. So in this case, we need to look at where they intersect in order to find the bounds for our integral. So we can see they intersect at 0 and at 1. Because that point is labeled 1, 1. So we're going to integrate from 0 to 1 of y top minus y bottom, and that'll give us that yellow shaded area in between the curves. Okay, so area equals 0 to 1, y top minus y bottom. So dx, so that is integral from 0 to 1. So the top, and you should put them in brackets so you don't mess up the negative sign. So the top function is 2x minus x squared, and the bottom function is x squared. In this case, brackets aren't necessary, but in other questions they will be. So, okay, and we're just going to collect terms before we do the integral to make it easier. So 0 to 1, so it'll be 2x minus 2x squared dx. Okay, so to do this definite integral, I need to do the antiderivative. The antiderivative of 2x is just x squared, and the antiderivative of 2x squared is, so we bump the power up by 1 and divide by the power. So it'd be 2/3 x cubed. And we are going to evaluate this at 1 and 0. So this is 1 squared minus 2/3 times 1 cubed minus, when you plug in 0 into both of those, it's going to be 0. So I'll just put minus 0. And so you get 1 minus 2/3, so 1/3. Okay, you should always write your answers as an exact answer, so as a fraction and not as a decimal number that's been rounded, okay? If you know, most calculators can actually convert decimal answers into fractions, so let me know if you don't know. So always write your answers as exact, unless the question says to round it. Okay. Next question, a little bit trickier for this one. So this one is obvious which the top function is and which the bottom function is. And the next one, we're going to have to split it into two parts. Okay, so let's look at this graph. Again, I'll always give you the graphs, right, so you can see. Find the area between y equals sine x and y equals cos x, between 0 and 2 pi. I haven't labeled the graphs here, but I'm going to label them now. So this is y equals sine x in blue, and this is y equals cos x in red. And you can see there's a region where cos x is on top in this first region here, but then in the second part, it's on the bottom. And then in this region, the sine x is on the bottom, but then in this region, sine x is on the top. So we're going to have to split this into two parts. I'll call them A and B. Okay, so the area between the curves is going to be, so we're going to go from 0 to pi over 4, where cos x is on the top, minus sine x dx, plus, and then we'll go to, from pi over 4 to pi over 2, where sine x is on the top, minus cos x dx. That looks like a lot of work to solve. It's going to be a lot of plugging in. There is a trick for this question too. So you could do it separately like that and add it all together. It's going to take some time. Or we can take advantage of some symmetry here. If you notice, region A and region B are the exact same. They're symmetrical. So if we just calculate region A, for example, and multiply it by 2, we're going to get the entire shaded region. So let's do that instead, because I like to save time. So in the first region, cos x is on top. I'll just put in brackets here, by symmetry. Okay, so now we need to do the antiderivative. So 2 times, so the antiderivative of cos x is sine x. And the antiderivative of sine x is, or negative sine x is cos. And this is going to be all evaluated at pi over 4 and 0. Okay, so it would be 2 times sine pi over 4 plus cos pi over 4 minus, so this 2 is multiplied to everything, minus sine 0 plus cos 0. So when you're typing in sine of pi over 4, you need to make sure your calculator is in radian mode. So I'm going to just check that there. If you don't know how to change your calculator to radian mode, just let me know and I will help you out, or Google how to change my calculator into radian mode. What you will notice here is that you get a decimal answer for sine of pi over 4. Guys who have taken Pre-Calc 12 know that the answer to sine of pi over 4 is exactly 1 over root 2. But since not everyone's taken Pre-Calc 12, I'm not going to require you to know that. So we can just write our answer as a decimal that's been rounded off for this question. Otherwise, if we had all taken Pre-Calc 12, I'd require you to have an exact answer. But since we haven't, that's okay. We're going to round our answer. So just type everything into your calculator, and we'll see that is approximately 0.828, or 4 over root 2 minus 2 exactly. But this is fine for this question, since we are not going to need to know how to write the exact answer. Okay, so that was an example where you need to split the region you're looking at into two parts, because in one section, one function was on top, and then in the other section, the other function was on top. In this case, we were able to use symmetry to cut our workload in half, but you won't always be able to do that. All right, let's look at one last example, and this example is a little bit different. So sometimes you'll want to the region between two curves, but not where one is above the other one, but where one is to the right or left of the other one. So let's have a look at this region here in between these two curves. Okay, sometimes functions can be rearranged and written in terms of y instead of x. We'll see an example put down below. In that case, we can still find the area. We just have to flip around and do our integral in terms of y instead of x. So in this, when you do the, let me just define what that means. So f of y dy, if you do the integral in terms of y, what that's going to give you, let's say you have a curve that is f of x equals f of y. It's going to give you the area under the curve, but like in the other axis. So there's your function there, let's say. and it's x equals f of y, so it's written in terms of y instead of x. If you do the integral in terms of y, it'll just give you the area underneath the curve, but with the y-axis. So when you have this scenario here, you want the right function, the one on the right, so xr, we label that, is considered kind of the top function, okay? And we subtract that by xl, the left function, which is kind of considered the bottom function because it's closer to the y-axis. Okay, so let's do an example. So let's say we want to find the area between the curve y equals x minus 1 and y squared equals 2x plus 6. So let's just color in that area here. Okay, so you can see here the green curve, that's the straight line. That's going to be my right function. And we're going to be subtracting that from this purple curve, or I'll shade it in red because I don't have purple. This is going to be the left function. Okay, so if I want to do left and right instead of up and down, top and bottom, I need to rewrite these in terms of x instead of y. So I'm just going to erase some of that because that was too much. Okay, so, okay, there we go. So this curve here is y squared minus equals 2x plus 6. So I'm just going to rearrange it. I'm going to move the 6 to the other side. So I'll have 2x equals y squared minus 6, and then divide everything by 2. So I'll have x equals 1/2 y squared minus 3. Okay, so that function is the XL. That is the function on the left of the region we want to find the area of. And the other graph, the one in green, the straight line, y equals x minus 1, we're just going to rearrange that as well. I'll move the 1 to the other side, so it's x equals y plus 1. So you need to rearrange the graphs if they aren't already, rearrange the equations so that they're written in terms of y, so that we can do the integral in terms of y. Okay, so now to find the area. So we're integrating in terms of y. So the bounds for my integral are y values. So the low bound is at -2, and the upper bound for my integral is going to be at 4. So I'm going to integrate from y equals -2 all the way to y equals 4. Okay, and I'm going to integrate the right function minus the left function. I'm going to go from -2 to 4. So the right function is y plus 1. And the left function is 1/2. So this is where brackets are important to keep track of our negative signs properly. And notice I have dy at the end of my integral because I'm integrating with respect to y. Okay. So now I'm just going to collect like terms and rearrange this so that it's easier to solve the integral. So I'll write the y squared term first. So I'll have -1/2 y squared plus y, and the constant terms add to 4. Okay, now it's time to do the antiderivative. So for the y squared term, the power will be bumped by 1, and then we divide by 3. So the 1/2 gets multiplied by 1/3, so it makes 1/6. For the y, bump the power up by 1, divide by 2. And for 4, it becomes 4y. And we're going to evaluate at 4 and 2. Okay, just going to make sure I don't make any mistakes here. That looks all good. Okay, awesome. So now we're going to plug in 4 and -2. So I'll have -1/6 times 4 cubed plus 1/2 times 4 squared plus 4 times 4. And then I'll have -1/6 times -2 cubed plus 1/2 times -2 squared plus 4 times -2. Okay, so you can plug all that into your calculator. It's good practice because you're going to be doing these and you don't want to make mistakes. But I'm not going to do that in front of you. You can just believe me, it equals exactly 18. Okay, so I think that's kind of cool, this like random area that looks, yeah, with this curvy line, has an area of exactly 18. Okay, so today there's no textbook, actually for this entire unit, I believe, there's no textbook questions. So it's all worksheets, so they're in the package. So your assignment is just to complete the attached worksheet.